Let's talk about the brain. So when we're thinking about the reading and the writing part of the brain, there are four different things that are involved. There are what's called four different processors. Now, I do want you to know while we're talking about this, that the reading typically develops first, and then the writing follows that. Okay, so as we're going through and we're talking about the different parts of the brain today, be thinking about your child might be an amazing reader, and you might be looking at the writing like, well, what's going on over here in the writing? Why am I not seeing that translate over? So there are some things that we can do to help with that, but also keep in mind that we'll always see the skills manifested first in the reading, and then the writing typically follows after that. So that four-part processor, or those different parts of the brain, the processors that work together, one is the orthographic processor. The second is the phonological processor. Then there's the meaning processor. And then last, there's the context processor. We'll talk about what each one of those do and their roles within the brain and how they contribute to reading and to writing effectively for learners. Know that in most cases, a lot of this occurs on the left side of the brain, but there are some of the processors are kind of spread throughout and at the base of the brain, and we'll actually talk about that as well. An interesting fact, though, before we go to the next slide, is that reading actually starts at the back of the brain. So that's interesting to know. So let's dive into the orthographic processor. So this orthographic processor, it is located in the occipital lobe of the brain, and is actually referred to as the brain's letterbox. So why might we refer to it as the brain's letterbox? Well, here's a reason why it might be referred to as that. The role of the orthographic processor is to actually recognize letters when it sees it. So imagine this. There is the letter R, and the letter R, when the orthographic processor sees it, it actually is broken into parts. So we might have the line for the letter R, this back part of the R first, that the brain may see, the orthographic processor. Then it might recognize the curved part of the R as well. Then finally, it might recognize the slant part of this capital letter R down here. And I might put all of those three parts together and realize like, oh my goodness, that is the letter R. So the main role and responsibility of the orthographic processor, the brain's letterbox, is to actually recognize a letter when it sees it. So once it recognizes the letter, what happens next? Well, the next processor helps with that. So this next processor is called the phonological processor, and it's located in the base of the brain, in the frontal lobe in the brain. It's referred to as the left inferior frontal cortex, and it's responsible for a couple of different things. Pronunciation is this part of the brain, or occurs in this particular part of the brain. So does articulation, but most importantly, phoneme analysis occurs here. So what does that mean? Well, remember we had the orthographic processor over here. So here was that orthographic processor that recognized the letter R. Then what happened is that it sent the signal over here to the phonological processor, and it basically said, hey, okay, I've recognized that I have the letter R. Can you tell me what is the sound that the letter R makes? So that phonological processor is responsible for holding the sounds. And that's basically what that word phoneme means. It means sound. So then the phonological processor will say, oh, okay, it says as in red, ribbon, river. So that letter R that was identified by the orthographic processor, the sound or phoneme for it is now processed by the phonological processor. So already we can see how the letter, which we refer to as the grapheme, was identified in the orthographic processor, and the sound, which we identify as the phoneme, was processed in the phonological processor. So we see then how these two processors work together to identify the grapheme which is the letter, and the sound that's associated with it, which is the phoneme. So because of that, now we have some what we call phoneme grapheme association between these two processors. So already we see the miracle that occurs in just the two first processors in the brain, excuse me, just in the two processors of the brain. So we have that identification of the letter or grapheme, and we have the sound or the phoneme associated with it. So what happens next? What is the next processor, and what helps us to be great readers and writers? So let's dive into this a little bit further. So the next part of the brain is called the meaning processor, the meaning processor. And so this particular part of the brain, it actually is in various regions all across our brain. It also can be referred to as the semantic processing system. And we know when we say semantics, a lot of times we're wanting to know the meaning of specific words. And this particular processor helps us to be able to do that. It helps us to interpret the different meanings of the words, what we're actually looking at. So if we came across the word tint, we wouldn't know really which word we were referring to, whether we were referring to the tint that's on our car window, spelled T-I-N-T, or if we may have been referring to the word tent, T-E-N-T, that we might go camping in. That's a prime example of how this particular part of the brain helps with those two meanings. It helps us to be able to know the meanings of both of those. Then it really works in collaboration with the next part of the brain. That next part of the brain is called context, or the context processor. This particular processor is important in that it supports the meaning processor. So think back to our example where we had two words. We had tent and we had tint. Now, if we just saw both of those words, most of us would realize that tent on our car window is spelled T-I-N-T, and tent that we go camping in is spelled T-E-N-T. But what if we were brand new readers, really, we were still learning how to read, and we did not really know the difference between how those words were spelled? Well, then we would need to rely more on our context processor, because it is the context processor that digs deeper into the sentence that that word tent may lie in, and it reads that particular sentence and realizes like, oh, it said the mom and dad enjoyed camping in their tent. So now we realize which word we're talking about versus the one we're talking about tent on our car window. So now we can eliminate that. So this part of the brain is crucial in that it helps to support the meaning processor. It helps to lead to comprehension. It breaks down different sentences and the context of what's going on within the sentences. It helps us to realize the difference between synonyms and homophones and things like that, that sometimes makes it difficult to actually comprehend a passage that we may actually be reading. So we can see why this particular processor is so important. So already we've went through the four parts of the brain. We've talked about, and I think I want to go back real quick if I can in my slides here, so we can look at these again. We've talked about the orthographic processor and how important it is when it comes to being able to identify a letter when it sees it. How about the phonological processor? So its role then is to recognize the sound and to know the sound of that particular letter that was recognized by the orthographic processor. So these two really, really work hard together. Now, I want you to think about this. If these two are not as strong as they should be, then we begin to have learners spend a lot of time in their orthographic processor just trying to figure out how to identify a letter that they're looking at, or how to write a particular letter, whether it's written forward or backwards or not. Did I did I start up here at the top, or do I start down here at the bottom when I'm actually writing that? What does that look like? So that orthographic processor is key. Remember something that I mentioned early on, one of the whys for this particular presentation today is that 1 out of every 5 learners has dyslexia. However, research has also shown that an orthographic processor that is not as strong as it should be can also come across as if that learner has dyslexia. So I'll say that again. An orthographic processor that is not as strong as it should be can also look as if the learner has dyslexia. So that's why it's so important that we want to make sure that orthographic processor is nice and strong, that the learner can identify and write letters correctly. The orthographic processor is key because it is the basis of all of the other processors that work together. Now I'm going to take a drink of water real quick because I got to clear my throat. So excuse me on that. So that orthographic processor is key. Now, the phonological processor, because we naturally start making sounds when we are younger, before we actually are even introduced to letters, it actually has a lot more experience than our orthographic processor. So that's something to keep in mind. And then, of course, that meaning and context processor, neither one of those will be utilized as much if our learners are stuck trying to figure out how to write a letter or even a number correctly, or if they are stuck trying to figure out the sound that corresponds with the letter or group of letters that they are actually working on. So I just wanted to go back and point those couple of things out so that we can think about that as we move forward. And we're talking about the 4-part processor: the orthographic, the phonological, the meaning, and the context processors.